Hello everyone. Now we will do the question number 15. A small circular loop of area A and resistance R is fixed on a horizontal xy plane with the center of the loop always on the axis n cap of the long solenoid. The solenoid has m turns per unit length and carries the current I connected clockwise as shown in figure. The magnetic field due to the solenoid is in n cap direction. List 1 gives the time dependence of n cap in terms of the constant angular frequency. List 2 gives the torque experienced by the circular loop at time t is equal to pi by 6 omega. Alpha value is given. You can observe the values and all. Now, first case where they have given n value is 1 by root 2 sin omega t j cap and cos omega t. Now, you need to calculate the torque. Torque value, you know that m bar cross b bar. M bar cross b bar. First, calculate the value of m bar so that we can substitute there. What is a magnetic field? B bar is equal to due to solenoid. Magnetic field due to solenoid. Magnetic field due to solenoid can be written as B is equal to mu naught into, here number of turns per unit length is given m into I into n cap. So we can write the value is mu naught into mi divided by the root 2 into sin omega t j cap plus cos omega t k cap. We can write the magnetic field we have written flux through the small loop. Flux through circular loop. You can write flux is equal to b bar dot a bar. If you write the b bar and a bar values, we can see b bar value is mu naught into mi divided by the root 2 into, this is k cap, this is I cap, j cap and k cap is there. A bar value is always a into k cap. Reason is the small loop is placed in xy plane. So area vector is perpendicular to that xy plane. A k cap. So k cap and k cap terms only will be there. Remaining terms will not be there. Reason is j cap dot k cap is 0. So we can write mu naught mi by root 2 into area A into cos omega t. This is the flux through the coil. Now you can write the induced EMF. You know that induced EMF E is equal to minus d phi by dt. Substitute there, we will get the induced EMF value minus into cos omega t, differentiation is minus omega into sin omega t. So we will get plus only mu naught into mi divided by the root 2 into a omega sin omega t. Now induced current. You calculate induced current. Induced current I is equal to, let us consider this I induced value, that is E divided by the resistance R. Now substitute there, the induced whatever induced EMF is there, that is I. The magnetic moment also I am writing. Magnetic moment value can be written as m bar is equal to I induced into, here a bar will get. So I induced value is mu naught mi divided by the root 2 into r a omega sin omega t k cap. Here a into a square k cap. This is m bar value. Now we can write the torque. Torque is equal to, you can write m bar cross b bar. So if you write m bar cross b bar is j cap and k cap is there. This value is k cap. So j cap cross k cap is minus I cap and j cap cross k cap is 0. Now substitute there, mu naught and mu naught is mu naught square, m and m square, I and I square, and omega whole divided by the root 2 into root 2 r sin omega t. You can write sin square omega t. J cap cross k cap cross j cap. You substitute there, mu naught m square I square omega a square by 2r, value is alpha into, they have given that t is equal to pi by 6 omega, nothing but 30 degrees is there. So 30 degrees is sine square 30 degrees. K cap cross j cap is minus I cap. So we can get the values alpha minus alpha by 4 I cap. So we can see minus alpha by 4 I cap. So first one you can get the Q. Now second one you will see. Again second one we can see flux is equal to B bar dot A bar. B bar value is mu naught into Mi by root 2 into sin omega t I cap plus cos omega t j cap dot A bar value is A into k cap. So I cap dot k cap 0, j cap dot k cap is 0. Flux is 0. We can write that whatever torque is there, that will also 0. So we can see in the second case it will be like a second one is P. So if we see that this one and this one also same only. Now you will check for the third option. Actually if you check the fourth option, automatically you will get the direct answer while writing the exam. If you check that fourth option, it is sufficient for that. Okay, now third option will check. So we can write the third option is flux is equal to mu naught into Mi divided by the mu naught Mi by root 2 sin omega t I cap plus cos omega t k cap dot A into k cap. So overall you can get mu naught into Mi A divided by the root 2 into k cap dot k cap, it is a cos omega t. You can write I cap dot k cap is 0 and k cap dot k cap is 1. Now induced EMF and induced current, you will write E divided by the R. So this value is minus d phi by dt whole divided by the R. Substitute there, minus cos omega t, again we will get the differentiation is minus of minus will become plus mu naught Mi A omega divided by the root 2 into R sin omega t is I. Now magnetic moment value will write m bar is equal to I into A bar. You substitute there mu naught Mi A square omega divided by the root 2 into R sin omega t k cap. This is m bar. Torque. Tau bar is m bar cross b bar. Use m bar cross b bar. If you write the m bar cross b bar, mu naught square m square I square A square omega divided by the root 2 into root 2 2R into sin omega t. Here k cap is there, here cos omega t k cap is there. So we can write sin omega t into cos omega t k cap and cross product you have, right? No, k cap cross k cap is 0 and k cap cross I cap sin square omega t k cap cross I cap. You substitute there, you can get the whole thing value is alpha and sin square omega t is 1 by 4. K cap cross I cap is j cap. So you can observe that torque is equal to alpha by 4 j cap. Alpha by 4 j cap is nothing but we will get the this S. Okay, now again 1 by root 2 cos omega t term is given. You substitute there. Flux is equal to B bar dot A bar. B bar is mu naught into, directly I am writing, reason is we have done earlier also, mu naught into Mi divided by the root 2 into this is k cap, this is a k cap, j cap and k cap, cos omega t j cap plus sin omega t k cap dot A into k cap. You can write mu naught Mi A divided by the root 2 into sin omega t. That is a flux. After writing the flux, we will write the induced current. That induced current value is I is equal to minus 1 by R into d phi by dt. Whatever induced current is that I am writing, you write the induced current as I induced. Okay, so you can write differentiation of sin omega t is omega into cos omega t. So you will get minus only here. Mu naught into Mi A divided by the root 2 into R into omega cos omega t you will get. Okay, so magnetic moment value I into A bar. If you write I into A bar minus mu naught Mi A square divided by root 2 into R. A bar value is cos omega t into a bar value is a into k, so I wrote a k cap value. Now torque is equal to m bar cross b bar. We can see m bar in k cap and b bar is j cap and k cap, so you can write the value as minus mu naught square m square I square a square omega divided by the root 2 into root 2 2r and cos omega t. So you can write cos square omega t k cap cross j cap. So k cap cross j cap is we can write minus I cap. So we can write minus alpha cos square 30 degrees. Cos 30 degrees is root 3 by 2, so we'll get 3 by 4. So 3 by 4 into k cap cross j cap is minus I cap. We'll get minus I cap. So finally we'll get 3 alpha divided by the 4. 3 alpha by 4. 3 alpha by 4, we can get that R. So overall we can get the option C. Observe carefully, these are